Okay, this is Unit 5, Lesson 10.
So we're reviewing radical expressions and exponents.
So when we're dealing with root symbols, let's just say we have the 5, fifth root of like, I don't know, 243, negative 243. Now, what do I see here? So the first thing I want to do is find out what to the fifth power is negative 243. I'm going to worry about this negative sign later, right? And that's going to be equal to 3 to the fifth power, right? Negative 3 to the fifth power, actually. Writing this wrong, but this is equal to the 3. Remember, we don't have the 5 here. It's not the 5, because by doing this, you're going to get negative 243. The fifth root of this is equal to, if you were to distribute this, put this in, then you'd get negative 243. And this is not equal. Right. So, on the next note, let's start off with an example. Like, let's say I have negative 243, the same one, right? And then you have like a to the 7th and like b to like the 20th. You get the fifth root of everything, right? So first of which, you're gonna sort of break apart the actual number inside of the root. So you're gonna have 243 times a7 times b20. Now looking at the 5, we can split up a into, this is also equal to a5 times a2, because remember, when we're multiplying, we're essentially just adding it, right? But in this case, we're not going to be adding it. We're going to split it apart. So we have 5 and 2, right? And so now looking at the root, the number that we're going to use as the basis for the root, you're going to see all the multiples of 5, all the exponents of 5, right? 20. Is 20 a multiple of 5? 20 is a multiple of 5. That means that this already can be turned into a solid b4. Well, how do I get a b4? B to the fourth power. It's actually quite simple. You get the 20 from the b, you divide it by 5, right? You get a whole number, 4. If you don't get a whole number, that means that you didn't finish going through the entire thing. Like, let's say we have a7, and we use 7 divided by 5. We won't get a whole number, like 1 and like 2/5, right? 2/5. You won't get a whole number. So it's easier to keep a whole number out like this, so then you can easily do 5 divided by 5 is equal to 1, right? And a to the first power is just a, so this just goes to a, right? Now we already know what this one is, negative 243. Since I solved it earlier, it's going to be negative 3, right? So now these, the red ones, are going to be on the outside, while the blue ones are going to be on the inside. So you're going to have your square root with your 5, or the root with the 5, the fifth root. And you're going to have negative 3 on the outside, times a times b to the fourth power, right? And on the inside, what are we left with? We're left with this one, a squared, right? And that's how you solve for something like this. Now I'm going to divide rational expressions. So let's say I have something like the cube root of x squared, 9 times x squared, all over 2, right? What am I going to do first? Well, can I find the cube root of 9? No, since 9 is 3 times 3, right? So what I'm going to do instead is I'm going to do the square root, cube root of 9x squared, because I can't find the cube root of x squared either, over the cube root of the square root of 2, right? Now, how am I going to solve this? First, I'm going to multiply in order to get out the radical on the bottom. So I'll multiply it by square root of 2 to the second. Why 2 to the second? Because you're essentially, what you're doing is 2 to the first times 2 to the second, right? What is that? You add 1 plus 2, that's 2 to the third, right? So since we're finding the cube root, the 3's, they cancel out. So you're just left with 2. You always want to do this, right? So you always want the numbers. So you want the numbers right here, the exponent. If you add them together, you always want it to be the same as that of the number you're rooting by, right? So you want to have it at 3. That way the 3's cancel out, right? And so what you're going to get is you're going to multiply both the top and the bottom, right? Final answer would be, if you multiply everything, you get the cube root of 9x squared times 2 squared all over the cube root, sorry about that, the cube root of 2 to the third power. And you could simplify this. So 2 times 2, 2 to the second power is equal to 4. 4 times 9 is 36. So I have the cube root of 36x squared over. Now what is this essentially? If we have this, it's obviously going to cancel out. So you're going to be left with 2 on the bottom over 2. Right? And that's my final answer. Now there are some cases where you can't essentially solve it like that. What I mean is, if you have, let's say, 27 or x squared, and that's all the square root of this, right? To do this, you always want to simplify both the top and the bottom as much as possible in this scenario. X squared is already simplified as much as possible, but 27, what base number raised to another number is equal to 27? Well, we know that 3 raised to the third power is 27, right? So we're going to have 3 raised to the third power equal to 27. Now then we're going to be left with, what essentially we're going to be left with is the square root of x squared over essentially the square root of 3 to the third power. Now simplifying this, 3 to the third power is just 3 to the second power times 3 to the first power. And let's remember the thing I told you before is that you're going to have an imaginary 2. So you're going to use this number and divide this by this, right? And what are you going to get? You're going to get 3 on the outside, so on this side you're going to get 3 on the outside, and the square root of 3 all over x squared, the square root of x squared. And the square root of x squared is essentially this divided by 2, which is 1, right? So x, the top is going to be x. Now, we're not done yet since we don't want to have a radical in our denominator. So what we're going to do is we're going to multiply both sides by 3. I mean the square root of 3. Right, the square root of 3. And we're going to get, what is the square root of 3 times 3? Which is the square root of 3 squared. Right? And the 2's will cancel out, obviously. And you'd be left with 3. So 3 times 3 is 9. On the top, we're going to have x times the square root of 3. And that's going to be our final answer. Now I'm going to move on to radical exponents. Now, the thing we learned in class is that a to the b over c power is equivalent to c, the root to the c power of a to the b power, like that. Or we can also write it as c to the root of a, all of that to the b power. Now, what does this mean in actuality? Let's take an equation, for example. I'm going to use 6, the 6th root of, let's say, x to the 3rd power, right? So following what we had above here, following this and this, essentially, right? That's what we're giving right here in this equation. We're given this. We're going to be asked to turn it into one of these, or a radical exponent, right? And so this is b, right here. This is b. This is a, right? Let me use a different color. This is a. So what I'm going to do is, using this, I will get, this is going to be equal to x, a, b over c. Right? Sorry, this is going to be c, this is your c, and this is your b. So if you have b over c, you're going to have 3 over 6. Now you're going to simplify that, and you're going to get 1/2. Right? This is also the same as the square root of x. But for answering this problem, this would be the correct answer. So let's say we have something like 1296. I know it's a really big number, but let's say we have the cube root of 1296, right? All to the 2nd power, of course. So what does 1296 simplify into? That's the first thing you always want to ask when you're given a radical expression. What can you simplify out of this, right? Now, for me, I already know the answer. So to simplify this, this is essentially 6 to the 4th power, right? And we still have that 2 on the outside. It is all going to be the cube root of that, right? So now you're if you simplify it and you multiply, right? Since it's exponent to an exponent, you multiply. you'd be left with 6 to the 8th power, right? Now, how do we simplify this? Well, you know you have two possible scenarios. You want to get a multiple of 3. That's what we're trying to get as for the exponent, right? So let's see. What's the greatest multiple that we can get? So there's multiples of 3, 3, 6, 9, etc., etc. So from here we're stuck with 8, right? The greatest multiple we can get from 8 would be 6, right? So we have 6 to the 6th power times 6 to the 2nd power, right? Now simplifying this, you divide by 3 on this side, since you are doing this, and you'd be left with 6 to the 2nd power. And then you'd also put that cube root in there. Sorry if it was really messy, but cube root in here, 6 to the 2nd power. Now what is this? Now we're going to simplify this, right? We're going to have 36 on the outside, 6 times 6, 36, times the cube root of 36. Is it possible to simplify 36 cubed? Is that actually possible? No, it's not possible. So this would be your final answer. Finally, I'm going to talk about converting a radical exponent into a radical expression. Let's just take, for instance, negative 128 to the, let's say, 3/5 power, right? So using the property that we already know, this is your C, remember that. This is your B, right? So this is going to be equal to, from the previous thing, negative. I'm going to leave the negative on the outside. As you, right here, we don't have parentheses. We don't have that, right? And because we don't have that, we are not really going to put the negative sign inside of the equation. So we're going to leave it out. Right, we're going to have the negative out there. And we're going to have the 5, which is a C. So that means we're finding the 5th root of 128 to, sorry about that, the 3rd power. Alright, and what is 128? What is the simplest form of 128? I mean, what is the form where the base is at its simplest and it is raised to a whole number, non-fraction, whole number, right? That's not a negative either. So 128 is also known as 2 to the, let's see, 2 to the 2nd, no. 2 to the 7th power, which is, so we're going to have 2 to the 7th power, all of this to the 3rd power, and we're still finding the 5th root, right? So let me just simplify this, since we know that that multiplies. And we're going to find the 5th root of 2 to the 21st power, negative version of that, right? Now, what is this essentially equal to? We know you have, what is the highest number of a multiple of 5 can you get from the 21, right? We're going to be going up to 20, since 4 times 5 is 20. That's the highest you can get. So if we were to split this off, we'd have 22 times 20 times 2, and 2 alone is already 2 to the 1st power. So what is 2 to the 20th? What is the 5th root of 2 to the 20th? was just dividing this by 5. Right? You'd be left with 2 to the 4th. So on the outside, we have 2 to the 4th negative. Sorry about that. And we're going to have a negative, right, in the front. Square root of 2. Right? What is this equal to? Well, 2 to the 4th is 16. So we're going to have negative 16 square root of 2. And this is your simplest form that you can get. I hope you understood this lesson. If you have any questions, please leave a comment on this video, and I will try to answer it to the best of my ability. Thanks for watching, and good luck.